Page 385, lesson 7.5 is on determining outcomes of compound events. Compound events are things where we have more than one thing happening. So if you look at this, solve and discuss it. Cameron packed 2 pairs of shorts and 3 t-shirts for a weekend trip. What were some combinations of shirts and shorts that Cameron can wear while on his trip? And how many days will he have a different outfit to wear? So we're going to talk about some different options, different combinations of things he could wear here. I'm just going to go ahead on these shirts maybe. I'm going to give abbreviations: yellow, white, red, and then on the shorts, green, and we'll just say blue, I guess. More navy blue maybe, but if you're going to do N for navy, however you want to do that. That gives abbreviations, so then we can list out some different combinations and still be able to see everything what's happening. So one option here would be the red shirt with blue shorts. Another option would be yellow shirt with green shorts. Another option would be white shirt with blue shorts. Another option would be a red shirt with green shorts. Merry Christmas. Another option would be yellow shirt with blue shorts. Another option would be white shirt with green shorts. So that actually would be all the different options. And so he has 6 combinations. And so he would have 6 different days that he would be able to wear a different outfit. As we go through problems like this, that wasn't too bad, but if they had a lot more shirts and shorts, it might be a little bit of a job to actually write all those out. So there's actually different ways of getting the answers. If they don't tell us we have to list out all the answers, there's other ways that we can find the answer a little bit quicker sometimes. So I'll just mention that to you guys real quick here, and we'll talk about it as we go through this lesson. Another option you could do is you could put blanks for the different options that you have to consider. So we have an option of a t-shirt, and we have an option of shorts. And in these blanks, we can put how many options we have. So for the shirts, we have 3 options. For the shorts, we have 2 options. And then what this method allows us to do is it says we take these different options and we can multiply them together, and that should tell us how many different options we have altogether. So if we multiply those together, that would be 6, and if you'll notice over here, we found out that there were 6 different combinations. So this is kind of a shortcut way that we can figure out the answer if they don't say we have to list out all the different options. So if we look at example 1, Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family with 3 children that the children will be all boys or all girls. How can they determine all possible combinations of boys and girls in a family with 3 children? So if you look, each time there's an option that the child's going to be either a boy or a girl. And this is an example of a compound event, just like we had with the shirt and shorts. Compound event has 2 or more events. So with the shirt and shorts, that had 2 different events in it. This one actually has 3 events in it. As long as there's at least 2 events, it's called a compound event. So what they did over here is they made a tree diagram of the different options. So they started out with child 1 being a boy or girl, and then if child 1 was a boy, the next child could have been a boy or a girl, and then going off of that could have been a boy or a girl or a boy or a girl. So you can see at the bottom here they've got all the different options actually. So here's all the different routes that we could have on this tree diagram. And the question was, they were talking about was what the chances are that the children will be all boys or all girls. So only one route has all boys out of, there were 8 routes altogether. So there's a 1/8 chance, theoretically, of having 3 children and them all being boys. For girls, it's going to be the same, as you might expect. There's only 1 out of 8 routes where it's all 3 girls. The other options are somewhere in between. So we have an option here that's got 2 boys and 1 girl. This one also has 2 boys and 1 girl. And this one has 2 boys and 1 girl. So 3 out of 8 for 2 boys and 1 girl. And then we've got these 3 options I underlined in blue where there's 2 girls. So 3 out of 8 for 2 girls and 1 boy. And then, like I said, this 1/8 was 3 boys, and the 1/8 was 3 girls.